right, lesson 3.7. We're going to start off with a definition. Associated with each square matrix is a real number called its determinant, and it is denoted with symbols that look like an absolute value. So it does have like these vertical bars. Now when you look at this definition, there's actually terminology that maybe we're not quite so familiar with. It says associated with each square matrix. Does anybody remember what is a square matrix?
A square matrix is everything in by itself.
What do you mean? Can you give me an example?
So if you square something like 2 squared would be 2 times 2. So the matrix times itself.
Okay, a square matrix is one matrix, so it's not like times itself. What is a square though? You were on the right track. All the sides are equal. So what do you think a square matrix might be?
2 by 2, 3 by 3.
Good job. A 2 by 2, a 3 by 3. That's where the number of rows is equal to the number of columns. Good job. Okay. All right, and now you're going to see a connection to my warm-up. If I want to find the determinant of a 2 by 2, all you do is you start with the top left and you multiply the diagonal. A times D minus the up diagonal. Okay? So A times D minus C times B. And that was just like number 1 on our warm-up. All right, I want you to write this down. This was not printed in your notes. A 3 by 3 matrix requires the technique of the diagonal method. And one other thing to write down, determinants can be positive, negative, or 0. Okay? And I will show you in an example how we do the 3 by 3, but for now we're going to start with the 2 by 2. And determinants can be positive, negative, or 0. Okay? We got it? Alright, so here we go. In example 1, it says evaluate the determinant of each matrix. So here's what you're going to do. You're going to start with the top left in a 2 by 2. 5 times 1 is 5. Minus, and then you subtract the up diagonal. 4 times 3 is 12. Notice that this determinant has a negative value. It's negative 7. But determinants can be positive, negative, or 0. All right, now with the 3 by 3, we're going to use what's called the diagonal method. And what you need to do is you need to rewrite column 1 and column 2. And what you're going to do, though, is now I have 3 down diagonals. So watch very carefully what we're going to do, okay? You're going to start with that top left. And you need to have a parenthesis because I have more than one down diagonal. So 2 times 1 times negative 2 is negative 4 plus. I have to add up all the down diagonals. And then the next one, thank goodness, there's a 0, so that's just 0. And then the third one is negative 3 times 4, which is negative 12. Negative 12 times negative 4 is positive 48, and then close the parenthesis. So what you're doing with the diagonal method is you are adding the 3 diagonal downs. Minus, now I'm going to switch colors, and you're going to do the 3 up diagonals. So 3 times 1 times negative 3 is negative 9 plus, notice I did insert a parenthesis here. And then I have 0, yay, we like 0. And then negative 2 times 4 is negative 8 times negative 1 is positive 8. So this is 44 minus negative 1. So this determinant was positive. And remember, determinants can be positive, negative, or 0. Alright, so what we're going to do is we're going to pause here before we do the next concept. And I'm going to give you 4 problems to do determinants to practice. So turn to your warm-up section or a piece of notebook paper. And so we're going to just practice. The first 2 are 2 by 2s, and then the next 2 are 3 by 3s. Remember, determinants can only be found on square matrices.
D times D plus E times D. It should work. So then here, up here, was the other way. And it's the same. Okay. So I'm sure it was just what you entered. It was just something simple.
All right, how are we doing? All right, check with a neighbor. Check your 4 answers with a neighbor. See how we did. Whoa.
The last two. Negative 13 and negative 6.
So 1 and 2, I'm hearing 464. That's what I got. But then I'm hearing some giggles with the second 2. And number 3, what did somebody who feels confident, what'd you get? Noah?
Negative 13.
Yeah, negative 13.
Yeah, no, I had that too.
Do you guys see what you did if you didn't get it?
Y equals MX plus B.
No! Alright, how about number 4? Noah?
Negative 6. Dang it.
Incorrect. I thought you were on a roll. You are now humbled, aren't you?
Yeah.
What is it? Oh, you're so close. It's
28.
negative 28. Negative 28.
Haha, that's what I
I had both of
just
those,
wanted to say
so-
it.
You just said you wanted to say the wrong answer
Yeah, for fun.
for fun? Okay.
Y
So,
equals
here's 0. Here's negative 6.
So happy.
Yeah.
Made that really. The second one was really easy because of all the zeros.
Yeah, there were 2 zeros. Oh. Yes, you guys, something times 0 is 0. And that's 18. Negative 10 minus 18. There's your negative 28, okay? I know.
Says the doctor. Thus says
Yeah.
the doctor.
Anything times 0 is 0.
Yeah,
I was
zero.
looking at that one, and I was
Okay,
like,
we figure it out? What am I
Yeah.
wrong?
I got
I feel
Oh,
like
you got it?
an
Super.
idiot now.
Alright, let's go back to our notes then.
Here's the genius.
And we're up to area of a triangle. So here we go. If you have, and let me back this up a moment before we start talking about this formula. Back in geometry and even in elementary school, you guys have a formula that I think you remember for area of a triangle. 1/2 the base times height. Now, when you say area equals 1/2 the base times height, there's a qualifier. Your height has to be perpendicular. Well, on the ACT, they love to give you a triangle that looks like this, and there's no way to find the perpendicular height. This isn't a right triangle, and you can't find that perpendicular height. But what you do have is you might have the coordinates of the vertices. So now, what's so cool about determinants, you might be thinking, all right, I can find them, but who cares? Like, what's the big deal? There's going to be several applications over this lesson and next lesson. They're going to unfold, and here's the first one. You can actually determine the area of any triangle if you know the 3 vertices, and here's how you do it. This vertical bar, let me go back up to letter A. If you make the vertical bars that sort of look like absolute value, that symbol means you're doing the determinant, okay? So here, this means area equals plus or minus 1/2, and you have these vertical bars, and it's the first point, x1, y1, and ends in a 1, x2, y2, ends in a 1, x3, y3, ends in a 1. The reason why, well, maybe can you guys tell me why is there a plus or minus 1/2? It's not that we're going to get 2 answers. Does anybody know why we might need to put plus or minus out front? Right, okay. What do you know about area? Area can't be negative. So, but what comes out of a determinant? Positive, negatives, or 0. Well, if it's negative, I've got to multiply by negative 1/2 to change the area positive. So that's the only reason why you have that plus or minus. Alright, so let's look at an example, and then we're going to do one practice problem after this. It says, off the coast of California, California lies a triangular region of the Pacific Ocean where huge populations of sea lions and seals live. The triangle is formed by imaginary lines connecting these three places. I'm not going to attempt to pronounce them. They have coordinates -1, 41, 0, 0, and 38, -43. Use a determinant to estimate the area of the region. So watch what we're going to do. Area equals plus or minus 1/2. And then you take the first ordered pair, -1, 41, and add a 1. Then we do 0, 0, and add a 1. 38, -43, add a 1. Well, to do the determinant, it's a 3 by 3 square matrix, so I have to add the two columns. You'll want your calculator, because these are going to get into a couple of big products. And I want you guys to follow me. Don't jump ahead, because I want to show you some important notation. When you're doing this, the plus or minus 1/2 needs to be in front of everything. So we're going to actually insert a big bracket, and then to do my down, and I'm just doing a different color so you can see, this is 0 plus, all right, we need our calculators, 41 times 38, 1558, plus, thank goodness we have another 0. Then we're going to do minus, and then we're going to do the up. So that's 0 plus, now that's positive 43 plus 0. Notice I'm going to close the bracket. I need plus or minus 1/2 until I figure out if this number's positive or negative, and then I'll change it. This is 1558 minus 43. Now I know that's going to be positive, so I'm going to drop the plus or minus and make it a positive 1/2 times 1515. They did not tell me the units, but area is in square units. So I'm getting 757.5 square units. But I want you to look back through the problem with me. Do you see that we started with plus or minus 1/2 and a big bracket? If you're not putting that, you're only taking half of the first parenthesis. And that isn't what we mean. Okay? All right, go back to your paper that you did your extra practice on, and I'm going to give you one more. You didn't tell, did you?
I found it.
Don't. I didn't tell you guys that.
You found a button for it.
Uh,
What'd you find, Noah?
nothing.
That's not fair.
Magic.
Hey, Noah, I know something about
Use it.
you.
I'm putting this on the no calculator part.
Oh.
Noah.
Don't do that.
Looking for a button.
I used
looking
exploration.
button.
Under matrices, there is a determinant button, but I did not want you guys to be using it. Thank you, Noah, for sharing.
Wait, what?
You're supposed to do that when the teacher doesn't hear you.
This is
Don't use it. Don't use it.
Why not?
We're trying to learn how to do this by hand first. Okay. So try this extra practice problem, please. Find the area of a triangle with these vertices: 0, 0, 3, 2, 2, 5.
Now the temptation's there.
Yeah, I'm
No.
like,
I'm glad I didn't find it.
we can tell you where it is.
Okay. I'll take that.
This one's much easier because it doesn't have big numbers. If they were all like this, we wouldn't want to use
Oh
them.
my gosh, I feel like nothing but zeros here.
Was that like next lesson stuff?
Yes.
Oh.
You're just ahead, that's okay.
Those like I